Today we're looking at the surface area of a cylinder. So I'm just going to draw a cylinder. Okay. Now, I'm going to make the cylinder has a radius r, and the cylinder is going to have a height h. So, to do the surface area, we basically have to find the area of each surface and add it together. So what is that cylinder made up of? Well, we've got a circle and another circle. We also have to unwrap this. This is actually a rectangle that's wrapped around the circle. So I've got a circle plus a rectangle that wraps around. It wraps around one of these circles or both of them. However, so with each circle, I've got radius r. So what is the area of each circle? What's the area of this circle? Area is pi r squared, and the area of this one is pi r squared. But I have to work out the area of the rectangular piece that wraps around the circle. So what I need is this distance around here. That's the circumference of the circle. And then times it by the height. So this distance here is the circumference of one of these circles, because that piece there wraps around there, and this is my height. So the area of this piece is length times breadth, length times width, whatever you want to call it, which is what? 2 pi r times h, 2 pi r h. Therefore, the formula for the surface area of a cylinder is 2 circles. How do I do 2 circles? 2 pi r squared plus the area of this rectangular piece, 2 pi r h. Now the reason, so we've got 1 circle, 2 circles, and the curved bit is 2 pi r h. The reason why we don't just give you the formula, I can ask you for the surface area of a cylinder that's closed. Can you tell me the formula for the surface area of a cylinder with the top open? So that's a closed cylinder. If the top is open, I've only got the base. Do you get it? So if I've got a cylinder, well, the reason is you need to know I've got my base. So the surface area with the top open is going to be just the one base. See, that's the circle base. So what you have to know is that these are the 2 circle ends on your formula, and this is the curved part. So the thing is, we'll either ask you fully closed cylinder, open on one end, or we'll ask you a pipe which has got no ends. That's why you need to know that the top bit is pi r squared, the bottom surface is pi r squared, and the curved bit is this distance, which is 2 pi r times h. That's why you need to know how the formula has been put together. So if you've got, with the top open, it's 1 circle plus 2 pi r h, which is the curved part. And now can you give me the formula for, so this bit's open, that's the second one. Can I now have the formula for surface area of a hollow cylinder? You know what I mean? Of just a tube. A hollow cylinder. You know what I mean? No top, bottom. No top or bottom. So what is it? It's just the curved part. It's only the curved part. So surface area of a hollow cylinder with no top or bottom is only the curved part. So I've only got the curved bit. I mean, I know they all look the same, but I've only got that bit. The top and the bottom are open. Okay? That's why you need to recognize the 2 pi r h as the curved part. And you can easily, you know the formula for area of a circle, pi r squared. Every time you see a pi r squared, 1 pi r squared, it's 1 circle. 2 pi r squared are the 2 circles. All right? And that's it, pretty much, for the theory for this. Okay. Oh, but we were also going to do half circles, half cylinders, quarter cylinders, slices of nice cheese, you know, wedges of cheese. Okay. Cool. Find the surface area of this closed cylinder. I'm going to give you the diameter this time. And the distance is down here and the diameter is 10. And I'm going to go that the height is also 10. So find the surface area of this closed cylinder. Okay, what you will do, you'll write out the formula first. Surface area is 2 pi r squared plus 2 pi r h. Really good idea just to write down next to your diagram what the r and the h are and then just substitute. Be careful, what's your r, radius? What's your radius? Well, my diameter is 10, my radius is 5, my height is 10. Okay, so the radius is 5, the height, that's the height of the cylinder. So we just go 2 pi times, the radius is 5 squared, plus 2 pi times 5 times 10. Give me exact, please. What's 2 times 25? 50 pi plus, what's this one? 5 times 10, 100 pi. See, you don't even need a calculator yet. 150 pi. And pi is roughly 3, so your answer should be 460, 470, something like that. What do you get? 400 and? So girls, notice I haven't even needed a calculator up to this stage, and then I just put 150 pi in my calculator. So 471.2 centimeters squared. I just did that to one decimal place, or even, you know, to the nearest whole number would be fine, seeing as I was given measurements to the nearest centimeter. So I'd probably just go 471 to the nearest whole number. Yeah, that'll do. Approximately. Next is C, 7C. So if you want to draw that. And we'll be doing 7E as well. Before we start, we're finding the surface area. This is closed on top. What shape is this on top? Yeah, basically this is a cylinder that's been sliced down the middle, but this is still a surface here. So basically what I've got is a rectangle, which is 5 times 4. What else have I got? Tell me about these two. What are they? They're 2 semicircles. That's great, because 2 semicircles makes a full circle, plus I've got a full circle with what? Which measurement did they give me?
4.
Diameter. So I'm going to go here, diameter is 4, radius is 2. So notice I'm just planning it out at the moment. I'm not doing it all. I'm just seeing what I've got. I've got the top bit. Girls, that's how you work with it. The top bit, the 2 side bits, you know, you're getting some marks in your question, all right? And then I've got how much of the curved surface area? Half the curved bit. So I've basically got half of the curved bit, the curved surface or curved part. Now what's this? So let's look at the formula. So we've got 5 times 4 for this, plus, isn't half the curved part a half of 2 pi r h? I'm going to fix it now. So girls, I've got the rectangle on top. I've got a full circle. The 2 semicircles give me a full circle. And I've got half of the curved part, which is a half of, because I know that the curved part of a full circle is 2 pi r h. So I've got a half of 2 pi r h. Got it? So now, what does that give me? 5 times 4 is the rectangle, which is 20. The full circle is pi r squared, which is pi times, what is it? Pi times what? 2 squared, which is 4 pi. And half the curved part is a half of 2 pi times, what's the radius of the circle? And what's the height of the cylinder? 5. Now, girls, what's a half of, well, no, nearly. Be careful. A half of 2. Or you can do a half of that too. Do you know what I mean? Or you can do 5 times 2 is 10, 20, a half of that is 10. When you see a half times 2, just wipe it out. A half of 2 is 1. So it's 10 pi. Notice I haven't even used a calculator. So what is it? 20 plus 14 pi. You know, pi is about 3.1-ish. So you're looking at about 45, 65, 64, 63 point, you know what, 98, whatever. I'd say that's approximately 64 centimeters squared to the nearest whole number. Okay? Look how the measurements were given to you as whole numbers. You don't go and quote your answer to 6 decimal places. All right, so I would just roughly, you've got your, that's close enough, 63.98. You can put to the nearest whole number there. All right, so again, it's all in how we set this up. Let's just look at all the surfaces, try and combine some of them together and make it a bit easier. Let's look at the next one. We're going to do the same thing again. We got any flat pieces? Do we have any parts of circles that can be combined? Yes. And what fraction of the curved part do we have? All right. Before we start, look, I've got this rectangle at the back and I've got the rectangle at the base. So I've got 2 times rectangle. And my 2 rectangles are, what are they? 10 times 6. That's 10 as well. So 2 of those, 10 times 6, plus I've got 2 quadrants, 2 quarter circles makes a semicircle. Are you given the radius or the diameter?
Radius.
Yep. Got 2 with a radius of 6. I'll just go R is 6 so we know. And then I've got the curved bit. But what fraction of the circle? A quarter of the curved surface. Curved part, curved surface. So in terms of formulas, I've got 2 times 10 times 6, that's my rectangles, plus a half of pi r squared, isn't it? Of pi times 6 squared, plus, are we okay? So girls, when you draw it all out, you're going back to the most basic type of question, where you're just finding the area of that, the area of that, and the area of that. All right, and that's what I would draw them out, plus a quarter of, now the whole curved surface is 2 pi RH, so it's a quarter of that 2 pi RH. So you can bracket them all if you want. So, are we okay, girls? So just, you know, that's one question, that's one question, that's one question. That's how you think of it. So 2 times 10 times 6, that's 120. Plus, what's this? What's 6 squared? What's half of 36? So it's 18 pi plus, this one is a quarter times 2 pi times, what's the radius and the height? 6. If you want, I can write this as a half, just the formula, or are you okay with that? Pi times, do you want me to write r squared or you're okay? So a quarter times 2 pi times 6 times 10. So I've got 120 plus 18 pi plus, all right, girls, 60, 120, a quarter of 130. 30 pi, 120 plus, 120 plus what? 48 pi, beautiful. That's roughly 50 times 3, roughly. That's about 150. 270. What do you get? 271 point? Yeah, 0.2 what, roughly? 270.7 what? Just give me a couple. Etc. Dot. You could either go 270.8 or 271 to the nearest. All right? So I could go, the reason I did the other one to the nearest whole number is it rounded nicely to the nearest whole number. I'll just put to 1 dp for that one, roughly. Here and put r squared and then substitute it so you know where you're getting that from. A quarter of the curved surface. You have to know that the curved surface is 2 pi RH. All right? And if you can't remember it, you would just draw a cylinder, and you know that that's 2 pi r, and that's the height. So rather than learning it off by heart, this is why we show you how we get the formula, so that if you've forgotten, you know how to work it out yourself. These for homework now. So, girls, looking at this one, what have you got? You would do the base. Can you see what you've got on the base? You would do this front face, and the back would be the same. You've got the 2 side faces, so you want to draw them separately. Then you've got this semicircle, and what's on the other side? Another semicircle, so you've got a full circle. And how much of a curved surface do you have? Half. Are you okay with that? So that's how I want you to do. Be very systematic. This one here. All right, let's do all the rectangles first. Remember, you don't do inside the shape. It's just the surface area. Let's look at this one here. What have I got here? A rectangle. Then I've got we've got the rectangle. We've got a triangle here at the front. And what's at the back? What's on the bottom? So I've just done that wedge. So I've got this rectangle. Now I've got a rectangle down the bottom. I've got the triangle at the front. And I've got the triangle at the back. Now, what have I got here? And what's at the bottom? Another semicircle. See how I'm just going through it? Girls, this might be worth 4 marks. If you start doing, yep, I can see the rectangle at the bottom. I can see the slanted rectangle. I'll do that. I can see this triangle. There's obviously another one at the back. I'll do those two triangles. I've got a semicircle and another one at the bottom. Don't do one semicircle. Just do semicircle and semicircle. Makes full circle. I'll do the area of the whole circle. And what's here now? Half a slanted surface. Half of 2 pi r/h. Work is to do this water trough in the shape of half a cylinder. That would look like this. That's a water trough like D. That's what a water trough looks like. Semicircular ends. The length, you'd have to change the units here to do that. Okay, also for homework, I want you to try this question 9 here. So, you need to look at each surface. You need the surface area of the log, including the ends and the inside. So we've got the outside curved surface, outside cylinder. You've just got to make sure that you know what the radius of that outside cylinder is. So the diameter is 60, so the radius would be 30. You've also got the surface of the inside cylinder, and we can see from here, there's a little arrow pointing there, that the diameter of the inside cylinder is 20. So you know that its radius is 10. So that does the 2 curved bits on the outside and the inside. Here that they've given you this length, and you don't have, sorry, not fairly lucky, that they have given you this length, sorry. But notice it's in meters, so you're going to have to do some conversions. And then here we have an annulus, which is a large circle minus a small circle. You've got another annulus there as well. So we've got, you'll have to do 2 annuluses, or annuli, sorry. So remember, you need to do large circle minus small circle, and you'll have to do that twice. Also try question 10 where you've got this roller. That's just a handle there. That's not a solid piece. It's just a handle. So you've got your curved part and you've got your 2 ends, but they only want you to find the surface area of the curved part. And then they want you, remember the roller rolls over the ground, and then they'll want you to work out the area of crushed rock. So remember, that's going to roll over the ground. That can be pressed after 1 revolution, so 1 turn and 20 revolutions. But notice the surface area here is in centimeters squared, and here the area is in meters squared. So you're going to have to do an area conversion here, okay? And you've already been practicing giving answers in terms of pi. So if you want to check your answers, if you come to question 11, for any questions that you've done in question 3, if you do them all in terms of exact, and then write the decimal answer, you'll be able to check those answers in question 11. Okay, and I think we will do some of these ones. Okay, I'm just going to do this one as an example. Okay, so I've drawn it out here, not as well as the one in the book. So what do I have? I have 2 sectors, basically. So I have 2 of this shape. Okay, so 2 of those. I have this rectangle here, which is 6 times 3, and this will also be the same. Now this sector has a radius of 6, okay? So then I have plus 2 of my rectangles that are 6 times 3, and then I have that curved surface around the back. Now, what we've been doing before is saying we've got a quarter of the curved surface, or we've got a half of the curved surface. Now, this time, it's not simply just a quarter or a half, but you've got 225 degrees out of 360. That's the fraction of the curved surface you've got, times, now the formula for the curved surface is 2 pi RH. So it's pretty much the same as what you're doing for when you're finding the area of a sector, but it's that fraction of the curved bit, so of the 2 pi RH, which is the curved surface, or the curved part. So let's set up our formulas. So we've got two sectors like that. So 2 times, now the area of a sector is theta out of 360 times 2 pi r. That's how we find the area of a sector. So our area is going to be 2 times 225 over 360. The reason we've got 2 is that we've got 2 of these sectors, one on the top, one on the bottom. So it's 2 times 22 over 360 times 2 pi times the radius is 6. That's our first shape. Plus, we've got 2 of these rectangles at the front here. So I've got 2 times 6 times 3. And then I've got 1 curved surface. Okay, so I've got 1, or a fraction of my curved surface, which is 225 over 360 times 2 pi times the radius is 6 of the curved surface. And the height of the curved surface is 3. So now working this out, I've got 2 times 2 times 6, that's 24 pi times 225 over 360. I'll just simplify that fraction, or you can, is 5/8, right? Plus, but you could do it all in one go. From here I can actually see if 225 over 360 is 5/8, I can see 8 goes into 24 3 times. This is actually 15 pi. So you can actually just put that in on your calculator if you want. Plus I've got 2 times 18, which is 36, plus, again, that's 5/8 times, 6 times 3 is 18, 18 times 2, that's 36 pi. So I've got 15 pi plus 36 plus, just simplifying this over here, 4 goes into 8 and 36, but you could just do it on your calculator and you'd get 45 over 2 pi, or 22.5 pi. So just adding these, if that's 22.5 and 15, that's 37.5 pi plus 36. And then you can now work that out to how maybe 1 decimal place, okay, on your calculator.